Okay, welcome to your e-learning video for today. We are going to work on section 5.7 in the textbook. And so what we're basically going to do is use proofs or strategies to prove parts of a triangle congruent. Okay, so I have some notes that I've put in the assignment. If you want to print them out and just fill in the blank, that's totally fine for today. We can kind of work through this together. If you would rather just watch the video and copy notes down in your notebook, that would be all right also. But there is a certain process we're going to follow for all of these. So we're going to use some proofs, and then I'm going to assign you guys some homework out of the online textbook. Okay, CPCTC. Okay, what that stands for is corresponding parts of congruent triangles. Congruent. See, always good to use pencil in math. Triangles are congruent. Okay, and we kind of did this in maybe the first section of this chapter where we had to show that each corresponding part was congruent in order to prove a triangle congruent. Now in this case, we're not going to have to do that, but we might use what we know about congruent triangles, prove two triangles congruent to each other, so that we could say two segments of the triangles are congruent to each other. I think you'll see as we work through here. Okay, we use this when we are asked to prove parts are congruent. Parts of a triangle, we're talking about sides and angles. Okay, but first, before we can prove these parts are congruent in these examples, we must prove the triangles are congruent. Okay, so we're going to use all those things we learned to prove triangles are congruent. We had side, side, side. We had side, angle, side. We had angle, side, angle. We had hypotenuse, leg. Can't remember off the top of my head if there were any more, but all these things in order to prove triangles congruent. And then we can prove parts of the triangles congruent to each other. Okay, so let's work through a couple of them here. So here, the first one we're going to start with is we have, oops, too small. We have this shape right here, and it's given that segment AB is congruent to segment AD, and segment BC is congruent to segment CD. So the first thing we need to do is kind of mark up our drawing with the information they've given us. So we know AB is congruent to AD, and BC is congruent to CD. Okay, we want to prove that angle BCA, so BCA is congruent to angle DCA. So we want to prove these two angles right here are congruent to each other. Okay, so already I can see that I have two corresponding sides of triangles congruent to each other. So what I'm going to use is congruent parts of congruent triangles are congruent. So I'm going to say if I can prove that these two triangles congruent to each other, then I can prove these two corresponding angles are congruent to each other. So let's work through the proof together. So I'm going to start with my statements here. I know AB is congruent to AD, and that's a given. I know BC is congruent to CD, and that's also a given. And then remember what we look for first. These two sides that these two triangles share this common side, then we know they're going to be congruent to each other using the reflexive property. So AC is congruent to AC, and that's the reflexive property. And then we have to say, before we can prove these two angles are congruent to each other, we have to first say that the triangles are congruent to each other. That's this right up here. We have to first prove the triangles are congruent. So now we can say triangle ABC is congruent to triangle ADC, and that's by using side, 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 right? The three congruent sides. So because these triangles are congruent, then all corresponding parts of the triangles are also congruent. So angle BCA is congruent to angle DCA using, we can just abbreviate, corresponding parts, that's a B, corresponding parts of congruent triangles are congruent. So that's what we're doing in this lecture today. So we're going to work through a couple of these pretty straightforward. We're going to go through one type of not a proof, but a strategy using congruent triangles from the book, and then you guys can start on your homework. So let's look at this one. All right, again, we're going to start by looking at our given information and marking up the triangle. Okay, so we are given that PS is parallel to QR. So PS is parallel to QR. All right, we're also given that QPS is congruent to SRQ. So these two angles are congruent to each other. All right, we need to prove that PQ, the side right here, is congruent to RS. All right, so we have an angle congruent to each other. Let's see what else we can find here. Let's start with what we have. So we know PS is parallel to QR. All right, when I look at my picture, I know that I'm going to have to prove that this side, we can look at that, reflects this property, that'll be equal to each other. So I have a side, an angle and a side, and I know if these are parallel, this is a transversal. So I also know that these two are equal to each other. So here I have angle, angle, side. So I know I can use angle, angle, side to prove these two triangles are congruent. Now I just have to work through the steps. So given, I also know angle QPS is congruent to angle SRQ. That's a given. Then I can prove these two angles congruent to each other. So right here I have an angle, right? I need another angle. I'm going to do that right here. I know these two are congruent to each other using alternate interior angles. Okay, and that's going to be angle PQS is congruent to angle RSQ. So now I have angle, angle. Now I need side. So this is my side right here. I can say QS is congruent to QS using reflexive property. And then I need to state, before I can use this congruent parts of congruent triangles are congruent, I need to state that the two triangles are congruent. So now I can say triangle PQS is congruent to triangle RSQ. And I used angle, angle, side for that one. So then all corresponding parts of those triangles are going to be congruent to each other. So now I can say corresponding parts of congruent triangles are congruent. And that's what that proof looks like. So again, we use the same steps as we work through all of these. We try to mark up our drawing with what is given. We try to look and see what we have and see almost which method we want to use, which triangle proof. Here we saw angle, angle, side was going to probably be the easiest. And then we just work through the steps. All right, let's do another one here. We're going to do just a couple more, and then I'll let you guys kind of move on. Okay, so we are given These just get a little more complicated as we go. So we are given that x is the midpoint of wy and vz. So if x is the midpoint of wy, that means these two are going to be equal to each other. And if x is the midpoint of vz, that means these two are going to be equal to each other. And again, just like before, just like we talked in class, when we have a common side, we should automatically think of a reflexive property. One of the other things we want to look to first is vertical angles. So here we have a vertical angle, which means it looks to me like we're going to want to use side angle side to prove these two triangles congruent. Now that we know kind of the strategy that we're going to use, we need to work ourselves logically through the steps. So we need to talk about what's given. So x is the midpoint of wy and vz, and that's a given. Okay, secondly, we can say wx is going to be congruent to yx, and that's the definition of a midpoint. And we can say vx is going to be congruent to zx. That's also the definition of a midpoint. Now we've got to say that these two angles are congruent to each other. So angle WXV is congruent to angle YXZ, and that uses vertical angles. Okay, so now we have our side angle side, but again, we have to state the triangles are congruent before we can use the congruent parts. So triangle WXV is congruent to triangle YXZ, and we used side angle side for that one. And we have angle then XWV, which is what we tried to prove. XWV is congruent to angle XYZ, and that's congruent parts of congruent triangles are congruent. All right, very good. Okay, let's go on and do another one here. I angle papers when I write, so I don't know exactly why this is so angled, but it is. I'm going to try to keep it straighter, but I don't know. Okay, that's a little bit better. Right here it says JM bisects, so JM bisects KJL, and then JMK equals JML. So if JM bisects this big angle, then we know both of these are going to be equal to each other, those little angles right there. We also know that these two are going to be equal to each other. And again, we need to look and see that these two parts, these two segments right here, JM, are the same part of both triangles. So we can say that these two segments are equal to each other. So now we have angle, side, angle. So we know we can prove the triangles are congruent. Therefore, we can say that JK is congruent to JL because they're corresponding parts. But we have to work through our proof first. So JM bisects angle KJL, and that's given. So then we know angle KJM is congruent to angle LJM, and that's a definition of angle bisector. Okay, now, so we've got that angle proven. Now we can say angle JMK is congruent to angle JML, and that's a given. And then we can say that this line segment is congruent to each other. JM is congruent to segment JM, and that is reflexive. And then we can say the triangles are congruent to each other. So triangle JMK is congruent to triangle JML, and that uses angle, side, angle. So then we can say each corresponding part is congruent to each other. Segment JK is congruent to segment JL, and that's corresponding parts of congruent triangles are congruent. Okay, I want you to pause the video here and try to do this one on your own. Try to see how you would approach it. And again, just pause the video for a second, and then I'll put the answer under the document camera. Okay, I'm going to get ready to put it under the document camera, so make sure that you've paused it or have your work done. Okay, so this is what the solution looks like here. All right, we know that BC is parallel to EF, so we know this is a transversal and this is a transversal, right? We know D is the midpoint of BF, which tells us these two segments are congruent. We know these two angles are congruent using vertical angles, and using alternate interior angles, we know that these two angles are congruent. So we can use angle, angle, side to prove this. So this is the way they did it. And again, the order isn't as important. This is super important there. You have to have the triangle proven congruent before you can use the congruent parts of congruent triangles. Okay, so I think this is pretty simple. I want to work through one more. Just go through this example because this was one out of the book. So I think this is example 2 in your textbook, and I kind of like this one right here. So what they want to do is use the following method to find the distance across the river from point N to point P. So we can just pretend like we're frontiersmen, whatever, and we're trying to cross the river at this point right here. This is where we want to cross the river. We have no idea the distance across the river. So we can't measure it right now because we can't even cross it yet. We want to try to cross it there, but maybe we want it to be a certain distance before we try. So we need to just use things on this side of the river that we can measure before we cross it. So I like this strategy here. So they're going to place a stake K here on the near side so that this is perpendicular. So that this line NK is perpendicular to this line NP. All right, then they're going to find the midpoint, and they're going to put something right there at the midpoint. So now we know these two are equal to each other. Then we're going to locate point L here so that LK is perpendicular to this line right here, and that these 3 points are collinear. So how will this allow you to find the distance? What we have here, we know we have an angle that's the same, right? We have two sides that are the same. We also know that this is going to be parallel to this, which means these two sides are going to be equal to each other. So we can say these triangles are congruent using angle, angle, side, which means we can measure this distance right here from LK to find this distance from NP. So anyway, I thought that was interesting. It's just an example of how we can use congruent triangles. I don't know how applicable this situation is to real life, but I thought it was an interesting example and an interesting kind of using one of our methods here. And what we know about lots of things, perpendicular lines, midpoints, all that kind of stuff. All right, your homework is on bigideas.com. Go ahead and get that done. Remember, regardless of snow, we will have a quiz Wednesday. That's the plan. All right. Have a great snow day.